Hi, this is part one of a two-part talk on visualizing GitHub. I'm Dana Bauer, and my co-author is Idan Gazit. He's giving the second part of the talk after the break. So if you really love us, and I hope you'll stick around in this room for the next couple of hours. So I'm a geographer and a data analyst, and I adore maps. This one on the screen is my newest map crush. Some of you might recognize it as one of the Stamen watercolor tiles, and it's centered on my home city of Philadelphia. And in Philly, I'm really active in the Python community, and I run Python workshops for women through the local user group. So last year at PyCon, Idan and I realized that we had a lot of shared interests, among them data visualization and storytelling. So we came up with the seed of the idea for this talk. And over the last couple of months, we identified some really cool data to dig into. We experimented, and we found some really exciting things in the data. So we'll feel like we succeeded today if you're equally excited about some of the insights we're going to share with you. So first, the data set. Being really good members of the quantified self generation, we decided to focus on us and our communities. We decided to really look at the data that flows through GitHub. Developers across all languages share code and contribute to projects here. And there's enough data here that we thought we could make some really interesting inferences about behaviors and conventions within and across communities. So GitHub has looked at itself quite a bit. They've given users tools for visualizing their own activity, like this checkerboard map of commits. And this incredibly prolific guy here gives you a great example of that particular visualization. There are also timelines and charts within a given repository. You'll see many of these are slightly different representations of the same kind of activity. So we liked these visualizations, but we were curious about what other things we could find. And when we started, we weren't even sure what questions we could ask, and we didn't even really know what data we had. So we just decided to dive in and document what we found and share it with you today. So every big project needs a Bible, I think. And our Bible for this project was Ben Fry's book, Visualizing Data. And Ben is kind of a god in the data visualization world. He created a programming language called processing, and he was really a pioneer in the field of computational information visualization. So in this book, Ben outlines 7 stages of data visualization that we really used as a guide for our explanation. Acquire, parse, filter, mine, represent, refine, interact. And this was the approach that we decided to use for this project. So what we really liked about this approach is that it's flexible, it's iterative. So 2 key things. Fry talks about the importance of working with teams of people that have a mix of skills, stats, data mining, design, software programming, so that no step in this process is completed in isolation. You have people talking to each other. Also, the process isn't linear. Often you'll find yourself going back to earlier stages as you go through the data and develop new questions and insights as you're doing your work. So in this talk, I'm going to cover some of the first few stages of this process, really the dirty work of getting from data to information. And if you stick around, and I hope you do, the second part of the talk after the break, Idan is going to talk about going from information to meaning. And he's going to show you some really beautiful visualizations that will blow your mind. I promise. Okay, so step 1. For folks who work with data, you might know that this is often one of the hardest parts of the process and can be really time-consuming and painful. Not always, but it really depends on the data that you're working with. So for GitHub, this is a really large data set. There are 3.4 million users, and that number is from early 2013. 5.7 million repositories. So this is an ocean of data, especially for someone like me who's used to working with much smaller data sets. So how do we drink the ocean? One way is to try to use the GitHub API, but from one authorized account, we're rate limited to 5,000 requests an hour. And you could do some math here. We didn't really have that much time. And try as we might, there was no way we could get everyone on GitHub to auth themselves with us. Okay, so this was really the first part of the filtering process. We needed to find a way to get a meaningful subset of this data. So we started with the top 10 languages on GitHub, and they list these on the site. You might guess what they are. JavaScript, Ruby, Java, Python, Shell, PHP, C, C++, Perl, and Objective-C in that order. And GitHub would only allow us to scrape the top 200 repositories for each language. So we came up with two strategies for sucking down the data. We reached out to GitHub about our project and asked them to increase our rate limits, and they graciously upped it to 12,500 requests per hour. And we realized there are no limits on cloning repositories, so that was our second strategy for gathering data about activity within repos. Just wait. So in theory, we could have done some of this work on our own computers, but we knew we'd be working with a lot of data, even for just 2,000 repos. So we decided to go to the cloud, EC2 instances on Amazon. So this was really great and had a lot of benefits for us. First of all, flexibility. We weren't really sure what resources we'd need to pull and store this data. So how much space will 2,000 repos take up? Anyone want to guess? We guessed 20, and we were so wrong. So we started with 25, and then went to 50, and then 100, and it came in just under 100, so wow. And here's some basic summary stats for the top 2,000 repositories. WebKit is the really big one, and who knows what's happening with that tiny one. Okay, so another benefit to doing in this in the cloud is stability. Where do you want these long-running operations to take place? What if your laptop goes to sleep or disconnects? What if you accidentally shut your laptop when you're going to pick up your kid from daycare? Really, not good stuff. Pain, see, I talked about pain. Also, Amazon gave us the option to increase memory and CPU, and we started with a micro instance and soon realized we needed to move to the next size to do all the cloning. Also, speed, we didn't have all of the time to do this, so we wanted things to be a little faster. I'm in Philly, Idan is in Tel Aviv, and this is what we got at home. But Amazon was way, 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 way faster, so it made a lot of sense for us to do it that way. Okay, so Amazon has lots of tools for us. We had to take this naked server and give it some clothes, and eventually I'm getting to the Python, bear with me. So we used a shell script to get the instance up and running, and then we installed some of the tools that we needed for our work. We wanted to use IPython. We had to install all of those dependencies. So now we had a Python toolchain to work with the data we wanted to work with, and this was the last time we touched shell. So you can see, this is the shell script. This was really the lowest friction way for us to do it. So now we have our server, we have our tools, we need to get those repositories. We abused Fabric in a little way for this work, but it was a good way to abuse Fabric. We could have written a simple Python script to issue the shell commands manually, but instead we used Fabric locally because it has nice facilities for running the tasks that we wanted to run. And it just made it easy to mix Python logic with the shell commands. Okay, so now we want to start doing things with our data. After a few false starts on Amazon, we got the data volume attached to one instance at a time. We made a snapshot, and we actually made it available to everyone. This was really a start of a much larger project for us, and we're hoping that a lot of other people will use this data to explore this one snapshot of GitHub and come up with some other interesting visualizations. So every time we launch an instance, it attaches our data. So now, playtime. We have this, what are we going to do with it? We have our working environment, and now we want to start exploring what we have there. So we were working together on this project, but we had some challenges. I'm in Philly, as I said, Idan's in Tel Aviv. How do we work remotely? We can't really sit next to each other in a coffee shop, and we wanted to create some kind of environment where we could see the work that we were doing. So when we launched our Amazon instance, we also launched IPython. And this was an environment where we could see what we were working on and do some initial digging into the data and have a record of it that we could share with each other and we could work on at the same time. So one of the things about working with IPython Notebook is that when we had some of these long-running tasks, if we lost the connection, close the laptop, pick the kid up from daycare, we really, in the IPython Notebook environment, rather, we lost where we were in the process, and we couldn't see the output in real time. We knew it was still running, but that was kind of problematic. So, dear IPython devs, we heard that you just got a lot of money, and we want a pony. We want IPython Notebook to work in real time that will show us the true state of whatever we're running so that we don't have these problems with losing the connection and losing track of what we're doing. So we came up with another way to work together. Like I said, IPython was great for that initial exploring, even though we had some problems, but it wasn't good for these longer running things. We also made sure that every EC2 instance came up with a tmux session. And this was new to me. It's sort of this all singing, all dancing, wonderful thing. So if any of you understood Inception, I loved it. I'm not sure I completely understood it. This is kind of a good analogy, shells within shells within shells. But the best part about it is that even if it disconnected from the server, for whatever reason, flaky internet, we could still pick it up and find out where we were in the process and see what the output was. So this ended up being the way that we worked. We probably didn't use it as often as we would have liked to, but as the project continues, this will be a great way for us to collaborate. Maybe not so great for beginners, but once we got over some of those humps, it worked out well. So yes, you know, being able to see each other code for me was magic. And when you're working Philly to Tel Aviv to Philly, it's really a great way to see what your partner is doing. Okay, so we have the repos. That's our primary source of data. It's on Amazon. And now we have to think about how we're going to structure the data. And in the beginning, we realized that we were going to be exploring, the results wouldn't necessarily be final, and that our representations might change. So we ended up using Mongo for a couple of reasons. We could get a hosted version for just a few bucks, and maybe you're sensing a trend here. We like to refer to our setup as data crunching on a budget, and it worked really well for us. So basically, this NoSQL schemaless database was really important. It worked well for us, and it gave us a way to discover how to represent our data as we were working through it. So the relational database is a lot more useful when you know the relationships, but when we were starting out, we didn't. This was very much an exploratory process. Nothing says that we couldn't migrate our data later, and there are lots of really easy ways for us to do that with our various setups, but Mongo was the right tool for us at this stage. Okay, so that's only one part of the story. Git repositories contain a ton of information, but there are some things that we wanted to get through the API that you couldn't get from the repository. So this is an important thing to understand. You clone a repository, you get all of this great information that Git gives you, but you don't get this extra great stuff that GitHub adds. For example, watchers. This is something that people love to do. If someone tweets a great project, you watch it, you want to find out how it develops, and that might be one first way that you engage with that particular project. So if we wanted the full picture, that full network of interactions between developers and projects, we needed both lines of attack, the cloning and going through the API. Okay, so when we were hitting the API, we ended up using Celery as a task queue. And this worked really, really well for us. So we would write the tasks that made the API request, set a rate limit, we were off to the races. There were some things that we had to worry about here. 2 tasks can't share the same rate limit, and the 2 Celery workers don't know about each other's rate limits, so we had to be careful there. So we were kind of dealing with the same problems before. We used Amazon because we didn't want to babysit processes on our laptops, because that kind of sucks. So we decided to run this in the cloud instead. We could have done it on Amazon, but that was a little more painful. So we set up all of this on Heroku, the task broker, the result store, and this worked well for us too. There are tons of add-ons on Heroku, and that, again, made it easier to do this on our budget. Okay, so let's go to this step. So we have all of this data, and we're at the point now where we want to begin to understand what we have, what some of the relationships are, and what questions we can ask now. And really, the data, just the basic stats about the data we got are pretty fascinating and staggering. So almost 6 million commits. Over 93,000 distinct commit authors across the 2,000 repositories. And over 44,000 contributors. So some of this data was a little messy. People with misconfigured Git author settings, lots of things, strange things that happened when projects transitioned from older version control systems. So we had to do a little bit of mucking around with the data we got from the GitHub API as well. So this is what happens when you're working with a data set that is constantly changing. I mean, things were changing over the course of the few days or even few hours we were cloning repositories and pulling data. So there's distortion in the snapshot of the data. It's not perfect. There's some error. Repositories get renamed. Changes get made, users change their metadata. These are just things that you have to deal with when you're working with a data set that's at this volume that's changing so rapidly. So this is kind of tough when you're trying to imagine how to represent the data. You're planning out your data acquisition. You're trying to figure out what you'll need for a complete, coherent snapshot. But you're not really sure what's permanent. You know that it's changing rapidly, so you just do the best that you can. So one thing that's really great to understand about the data visualization process is that you're going to go back and refine your data. You might go back and acquire more data. It's really a process that moves back and forth, if you remember that chart that I showed from Ben Fry. So you really want to write your code in a fashion that you can rerun it, so that other people can run it, and that it works on this constantly changing data set. So this is the end of my portion of the talk. I can take a few questions, but if you stick around, Idan is going to come up and finish the talk. He's going to show you some really great visualizations, and he's going to pick up where I left off, working with the data, and tell you more about what we did with it. So stick around.
If you have any questions, please move to the mic and you can ask them.
Hi there. Is this on? So you talked about distortion in the data and becoming aware that some things didn't fit the pattern you expected. How were you able to determine that? I'm sure you weren't looking at the whole data set at once. Were you programmatically testing it somehow, or how did those problems manifest themselves?
Some of it was error. We got some error messages. We saw error in the data. We would go back and run queries again, and it became obvious that things had changed. So we weren't really tracking it programmatically. I mean, I'm sure that we could have done that, but it was hard not to notice, especially when we went back to get more data, that things had changed very quickly, even with in the span of a couple of hours.
So did you write all of the tools that you used for the actual data analysis, or were there libraries that you used that help with this, both like the fetching and the massaging?
So a lot of that will be covered in Idan's talk.
Okay.
I don't want to spoil the surprise.
Okay.
But I will say that most of it was not in Python. Sorry.
Well, I have a question.
Yes.
Who was sponsoring this kind of research?
Us. You know, I mean, I mentioned data crunching on a budget. This was really, you know, we were just really curious. Both of us love working with data. We both like to make pretty things. Idan makes really pretty things. So we wanted a really meaty data set that would be interesting to us, and that would be interesting to the Python community. So we had lots of initial questions, you know, how are people interacting? Who's contributing across languages? You know, and really the only way to get at that is to just decide you're going to take on this project on the smallest budget possible. And we were able to do that. We did get a little help from the folks at Github when they upped our rate limit. But that was the only sort of sponsorship.
And can I ask what that budget was?
So our setup on Heroku was about $30 a month. Maybe a little more than that. And I'm not quite sure what the final Amazon costs will be. We're still, you know, running that. So under $100 for sure. And snacks, so.
Okay, I guess you are providing your data to BigQuery. Are you using it? BigQuery, because it's a Google product.
I'm sorry, could you repeat that?
Yeah, so we can get your data from BigQuery sample, I guess. So sorry, so sorry.
There's a Google product called BigQuery.
Yeah, BigQuery.
Big what?
BigQuery.
Oh.
Query.
That's data. Look at data.
Oh,
Nice interactive content.
great. No, it's not a tool that I've used.
Yeah.
But thanks for the recommendation. I'll definitely look into that.
No. Yeah. So sorry. Are you using it? No.
No,
you are using MongoDB only. Okay. Thank you.
All right, don't move. Except for your break, right? Yeah.
Go ahead.
Okay, thanks. I think you said that your data is available. Can you say really quickly how to get it?
Yes, we'll share everything.
Okay.
So we wanted to make this available to the community, at least the snapshot that we have, so other people can play with it as well.
And so how do we get it?
We'll make sure that this Let me go back to the slide. We can. Shop away.
Thanks.
Yep.
So from how you explained how you acquired the data, it didn't seem as if you actually know like how representative these repositories are. Are you able to say anything about GitHub as a whole based off of your sampling method?
So.
I mean, you pointed out how many contributors there are,
right.
But we don't know if those. I mean, by definition, those projects aren't representative of GitHub, so you can't extend that out to say how many contributors are contributing to GitHub total, right?
Well, so in part 2, we'll explore that a little more so that you can see some of those relationships. I'm not quite sure. I mean, this is not. This is a snapshot.
A snapshot of a subset, right?
Yeah, sorry, a subset of the data.
Okay. And we don't know how large the subset is compared to the full data?
Well, so in the beginning, we got the numbers from GitHub about the full universe of. So here we go.
So those are the full numbers. Those were all of GitHub and weren't the numbers associated with your subset.
Right, and this changes fairly rapidly.
Okay. Sorry, I didn't understand that when you went through it the first time.
Sure.
Thanks.
Thanks.
Hi, can you say a little about how did you coordinate the time difference and which tools do you guys use to talk, to meet, the Skype, Hangouts? If you had a schedule to meet at night, stayed up in the mornings.
I love this question.
And I had one other thing. I'll come back when I remember.
Well, both of us have small kids, so that kind of you heard me mentioning about going to daycare pickup and effing everything up. So that, like both of us had small kids, so we had to coordinate around that. Time difference was 7 hours, so we staggered it. It was usually late night for Idan, late afternoon for me, and then Sunday was a little easier for us. We Skyped a lot, FaceTime, but the tools that we used for collaborative coding were great. I definitely enjoyed it. We didn't use it quite as much as we wanted to. We ended up sharing screens as well in Skype. So it worked out pretty well. I think as we develop the project more, we'll be relying more on, we hope, IPython Notebook, and again, working in Tmux.
I have one more question. How many hours did you invest in this? I mean, so far, or how long is this project?
Too many.
How do you split it with work?
Gosh, this was kind of a labor of love. So I'm used to tracking my hours for other projects, but it's ongoing. So we hope to keep working on it, but we've put in quite a bit of time.
Okay.
So far,
Thanks.
I'll have to think about that. And my husband might not be totally happy.
Great. Well, thank you very much, Dana.
Thank you.
And stick around for part 2.